regression models, algebra 2, trigonometry regions. You'll have to excuse my voice. Hopefully you can understand what I'm saying, but I'm definitely losing my voice a little bit here, but I think I got enough left to get through this video. These are regression models, and there should be an O in here for regression models, but I don't think you have this slide on your page anyways. So the previous video was about linear regression. And linear regression was when we had a correlation that, a scatter plot that looked like a linear regression. It could be a positive or it could be a negative correlation and things like that. But what if we have data that doesn't give a linear correlation? What if the data is kind of curved like that? Would you say this is a positive correlation? Well, it's not really linear. It's kind of curved. Or if you have data that kind of goes like this, it's not linear, but it is kind of like a parabola. So there are different types of regression models other than linear. The ones we should most be familiar with are things like exponential, which this problem is using, power, um, quadratic, things like that. But the calculator has all different regression models, and you've probably noticed a few that when we go into this section of our calculator, we see that we have linear regression, which we've used. Then there's quadratic regression, cubic regression, quart regression. There's another linear regression, ln regression, ln regression. That's from natural logs. That's a logarithm regression there. Exponential regression, power regression, sine regression. Exponential and power are probably the two most common you're going to see, especially exponential. When it's not linear regression, it's exponential regression, probably 80-90% of the time. But every once in a while, you'll still see power regression there too. But logarithmic regression, things like that. So there's different types of regression, and it's basically what is the what is the data kind of form. But these problems will always tell you, what type of regression model they want you to work with. So let me just do this example with you. The table below shows the concentration of ozone in Earth's atmosphere at different altitudes. Write the exponential regression equation. So exponential regression equation. The fact that it's an equation means we're going to have a y equals in front of it. Don't forget that. You will lose points if you don't have y equals when you're asked to write an equation. So y equals. That models this data. Rounding all values to the nearest 10,000s. Remember always to underline what you have to round to, because the most common error on these problems is people lose points for simply because they rounded wrong. So we start this exactly as we've been starting these problems, where we're going to put this data into our calculator. So here's our L1 and L2 columns, and these are separate variables. So let's take a look here. If we hit stat and then enter, it'll bring us to these columns. We could go up to the title, hit clear, enter to zap any numbers that's in there, and type in what the problem is showing there. So we got 0, 5, 10, 15, and 20. And I know I mentioned this in the previous videos, to be very careful at this point, because if you mistype a number here, it will definitely affect your answer, and you'll lose points there. And it's a silly reason to lose points because you typed it in wrong. All right, so that's all of the numbers in there. Quick check makes it look good. All right, now stat, right arrow to the calc screen. We've done one variable statistics. That's not this. The previous video we did a linear regression. Again, that's not this. Exponential regression is what we want. So we need to scroll down to exponential regression, which actually might be 0. And so yeah, you could just hit the 0 key and jump to it. But that's our exponential regression. Okay, a couple of things here. The X list should be L1. The Y list should be L2. The frequency list should be blank. So you want that to be clear. Now, if your calculator is different, if you do not have this type of software, it's not going to ask you this thing. So you have to type in L1, comma, L2, just like you did for the linear regression stuff. But you want your frequency list blank. These are not frequency values. And then we hit calculate. And and this is what we see. So let me drag this over, and I can work now from this. Okay, so they give you a model of what the equation should look like. A times b raised to the x. That's what exponential is, when your variable is x. Power is when you have x being, raised to things. But so a times b raised to the x, because we'll also see a times x raised to the b. That's what a power regression is. But this is a times b raised to the x. And so I'm rounding to the nearest thousandths. So my a value to the nearest thousandths would be 0.4, so that'd be tens, hundredths, thousands. So 0.488, tens, hundredths, thousands. That's 3 deep. The b value is 1.116. So a times b raised to the x. I'm not going to do this silly little symbol for times. We're going to write it as, so 0.488, and then the way I do times b is I do parentheses for the b, 1.116, because we know when there's a coefficient up against parentheses, that means multiplication. And then this is your exponent symbol, so your exponent is an x. If you were to write it like this, that's not an exponent, so you'll lose points there. So make sure you write it as an exponent. That's what exponential means, is that x is an exponent. So there's your equation, and a lot of times that's all the problem wants, is they want you just to type it in and go from there. You still get an R value on some of these, but we don't really talk about the correlation coefficient with anything besides linear, at least at this level of statistics. But often these questions will have a part B like this, using this equation, predict the ozone units at an altitude of 24. So the altitude is our x. So that means we're going to plug in an x value of 24. So, all right, a couple of things before I even get to this. Now, it always drives me crazy, but students lose points for the silliest reasons on this question. They don't have a y equals there. They round wrong. But sometimes when students do this question, they put down y equals 0.488 parentheses 1.116 parentheses, and they replace x with 24, which is correct. We do need to do that for part B. But part A just wants the equation. Find the equation. The equation has x in it. So don't think that this can count as your answer for the equation. No, this is using the equation for part B. But students do that all the time. I'm not really sure why. So when it asks for the equation, you need a y, an equal sign, and an x. If it then says use the equation, you have to rewrite it a second time with a substitution. That's what we see here. The way to evaluate this is simply to type it into your calculator as you see it. So we'll say 0.488 parentheses 1.116 parentheses raised to the 24, enter, and this one's to the nearest tenth. That's the other thing. When there's multiple parts to these questions, make sure you don't assume that it's the same rounding. See, this one wanted all to the nearest thousands. This one's nearest tenths. Students mess that up all the time. They assume I'm rounding to the same spot for all these problems. You got to read the question, underline those key pieces of information. So this would be y equals to the nearest tenth 6.8. And these are such easy questions, guys. I mean, we're just typing this into our calculator. The calculator's giving us the answer. We just got to write it down properly. But I've seen students get points off, and this is a very common Regents question. It's on there almost every year, this type of thing. So it should be an easy couple of points. You just can't fall for the traps like forgetting y equals or rounding, or forgetting the x, or assuming the rounding's the same, because it might not be. How could they make this question more difficult? Well, they can make this question more difficult if they gave you, say, y and wanted you to solve for x, because then you'd be solving for an exponent, which would actually require logarithms. So I'm sure we'll do one of those in class, but the vast majority of them are like this. Get the equation from the calculator and then substitute into the equation to solve it. All right, see you later.